Usually when we talk about like a medical diagnosis, there's this expectation of clinical precision.
Oh, absolutely.
Like you break your arm, the x-ray shows that jagged white line, and the doctor just points to the screen. Broken or not broken, it's clean.
Right. It's binary.
Exactly. But if you look at the software inside that x-ray machine or the
Uh,
software managing the hospital's database or even the banking infrastructure you use to pay the medical bill,
mhm.
that expectation of precision completely shatters.
It really does.
It's just we're operating in a landscape of chaotic manual friction.
Yeah, it is diagnostic muddy waters applied to engineering. I mean, we treat software development as this highly advanced futuristic endeavor.
Right.
But the reality on the factory floor is, well, it's a deeply fragmented manual grind.
And today's deep dive is about a blueprint that wants to eradicate that friction completely.
Totally wipe it out.
Right. We are unpacking a genuinely revolutionary document. It's titled Catalyst to Autonomy, an executive blueprint for integrating generative AI across the SDLC.
It's quite a title.
It is. But our mission here is to map out how artificial intelligence has moved, far beyond acting as just a fancy autocomplete in a developer's IDE.
Right. It's not just finishing your sentences anymore.
Exactly. This blueprint outlines how AI is fundamentally rewiring the entire software factory from end to end. We're going to explore what this means for the architecture of modern technology and what it means for you, the listener, as you navigate an increasingly automated world.
It's a huge paradigm shift.
Okay, let's unpack this. The title itself, Catalyst to Autonomy,
Yeah.
sets a very specific philosophical stage, I think.
It really does, yeah.
We aren't just talking about a list of new software features here.
No, not at all. We're talking about an operational paradigm shift. The focus of this blueprint is profoundly centered on the why.
The why.
Yeah, it advocates for moving away from systems that require constant human intervention just to stay functional.
Just to keep the lights on, basically.
Exactly. And moving toward an interconnected, self-healing ecosystem. The document calls this aspirational horizon NoOps.
NoOps.
Yeah, NoOps, a state where the infrastructure, the testing, and the deployment pipelines essentially manage themselves.
No operations. I mean, it sounds like the final utopian promise of tech, right?
It does sound a bit utopian, yeah.
But to appreciate the cure, we have to deeply understand the disease. Before we can analyze this NoOps future, we need to establish the baseline reality of what the blueprint calls legacy DevOps.
Right.
We spent the last decade championing DevOps as the ultimate solution, blurring the lines between development and operations to deploy code faster. But the blueprint argues we've hit a friction ceiling.
We absolutely hit that ceiling. And we hit it because, DevOps optimized the flow of work, but it didn't eliminate the manual toil required to maintain that flow.
So the work moves faster, but we're still pushing it by hand.
Precisely. If we look at the legacy column in this blueprint, it segments this friction into 4 distinct areas:
Yep.
coding, QA, infrastructure, and the pipeline. In the coding phase, the friction isn't necessarily about typing speed. It's about cognitive load and context switching. I mean, a developer doesn't just sit and write brilliant algorithms all day.
No, I imagine they don't.
They spend an agonizing amount of time writing structural boilerplate.
Ugh, just the plumbing.
Exactly. And when they hit a roadblock, they have to break their mental state, leave their IDE, scour forums or documentation.
Right, going down the Stack Overflow rabbit hole.
Exactly. And then they have to mentally translate a generic solution back into the highly bespoke architecture of their own company's code base.
It's like the cognitive equivalent of trying to write a complex novel.
Yeah.
But every time you need to structure a sentence, you have to walk to a public library.
Yeah.
Look up the grammar rule in a textbook and then walk back to your desk to adapt that rule to your specific characters.
That is a perfect analogy.
You just never achieve a flow state.
You can't. And then, assuming you finally get the code written, you hit the validation layer. The QA friction.
The dreaded QA layer.
Yep. The blueprint points to brittle UI scripts as the primary culprit here.
Brittle UI scripts.
Brittle is the perfect word for it. QA teams spend their days writing highly rigid manual test scripts to verify the user interface.
Right.
These scripts are essentially blind directives. They rely on fixed element locators. So if a single pixel shifts or a developer renames a CSS class,
The whole thing breaks.
the entire test suite shatters. The build fails, the pipeline halts, and a human being has to manually investigate the wreckage just to update a locator ID.
That sounds incredibly tedious.
It is. And while the QA team is drowning in broken scripts, the infrastructure team is suffocating under thousands of lines of manual Terraform configurations.
Oh, wow.
Yeah, the blueprint highlights how this leads to what they call hidden drift.
Hidden drift.
Yeah, you write a script to provision a server environment, but over time, manual tweaks are made directly to those servers.
Oh, I see.
Suddenly, the reality of the server environment has drifted away from the configuration code that supposedly defines it.
So they don't match anymore.
Exactly. You get mysterious deployment failures because the staging environment no longer matches the production environment.
Which I assume cascades directly into the final point of friction.
Right. The deployment pipelines themselves.
Because of all this uncertainty, the context switching, the brittle test, the infrastructure drift, the pipelines become these massive, blind, linear bottlenecks.
blind.
They run every single test against every single module for every single code commit, regardless of whether it's logically necessary.
Just to be safe.
Right, which creates a massive traffic jam in staging environments. It sounds like we upgraded from a horse to a sports car with DevOps, but we're still forcing the driver to get out and manually pump the gas every 3 miles.
While simultaneously repairing the potholes they hit along the way.
Exactly. And NoOps is supposed to be the fully self-driving car.
That's the vision.
The blueprint's answer to this massive accumulation of technical debt is AI-orchestrated NoOps. But, here's where I have to push back on the premise a little.
Okay, let's hear it.
The document explicitly defines NoOps as a state where 95% of routine operations are automated.
Yes.
In the messy, complex reality of enterprise software, aiming for 95% automation sounds less like a strategic goal and more like, flashy executive marketing fluff.
I get why you'd say that.
Right. Is that number actually mathematically defensible?
It becomes defensible when you strictly define routine operations.
Okay, define it.
The blueprint is not suggesting that 95% of the cognitive problem-solving required to build software is automated. It's targeting the boilerplate, the script maintenance, the manual server provisioning, and the pipeline babysitting.
Ah, the plumbing we talked about.
Right. When you analyze a typical sprint cycle, the sheer volume of hours dedicated to wrestling with the machinery of delivery rather than designing the logic of the application is staggering.
So it's about reclaiming that specific time.
Exactly.
Oh.
Automating 95% of that specific definable toil is mathematically plausible if you have intelligent agents that can parse context.
That distinction makes a lot of sense. And it's something anyone can relate to, regardless of their industry.
No, for sure.
How often do you hit friction ceilings in your own non-coding workflows because of manual toil? Where the administrative metadata of the job consumes more time than the actual core function of the job.
Everyone experiences that.
Right. And this blueprint is laying out a highly specific map to eradicate that administrative metadata for software engineers. It divides this map into 4 foundational pillars, starting at the point of inception.
The very beginning.
Pillar 1 is the stay-in-the-flow coding engine.
And the entire philosophy of this first pillar hinges on that exact phrase, staying in the flow.
Staying in the flow.
The blueprint positions the AI assistant, specifically utilizing models like GitHub Copilot, not as a code generator, but as a context processor.
A context processor.
This is the crucial leap from legacy tools. Generic AI code generation is practically useless in an enterprise environment because it lacks awareness of the surrounding architecture.
It's just spitting out code in a vacuum.
Exactly. The blueprint details how the AI natively digests organizational design patterns and the historical context of previous pull requests.
So it's basically reading the room before it speaks.
That's a great way to put it.
It understands the bespoke coding standards of your specific team. So when you prompt it, the generated code structurally aligns with the existing ecosystem.
Right. And the document provides a very concrete business example of this contextual generation.
Oh, yes, I saw this.
It looks at the implementation of an OAuth2 PKCE middleware.
Okay, unpack that a bit.
It's a standard cryptographic security protocol for authentication, notorious for requiring highly specific, tedious boilerplate.
The really boring, repetitive stuff.
Exactly. The blueprint claims that by using the AI, the time spent on this workflow drops by 33%.
33%.
Yeah, taking a 42-minute task down to 28 minutes.
14 minutes saved on a single middleware implementation. I mean, in isolation, that sounds kind of incremental.
It does. But the blueprint isn't optimizing for a single developer, it's optimizing for scale. When you apply a 33% reduction in boilerplate generation across 50 similar tasks a week, multiplied by 1,000 developers in an enterprise organization,
Oh, wow.
you are reclaiming tens of thousands of engineering hours.
That's massive.
You are fundamentally altering the capacity of the organization. But the efficiency gains don't stop at the application logic. The blueprint notes that the system utilizes pre-commit hooks to automatically generate the corresponding unit test skeletons.
So, meaning the moment the developer prompts the AI to generate the OAuth middleware, the AI simultaneously generates the structural outline for the jest tests required to validate that middleware
Yes.
before the developer even officially commits the code.
Precisely. It tackles the creation and the initial layer of validation in a single parallel motion.
Here's where it gets really interesting, though. Generating 30 lines of bespoke context-aware code in under 2 seconds, alongside the testing skeleton, creates an incredible velocity at the top of the funnel.
Oh, unbelievable velocity.
But if the AI is generating code at machine speed, doesn't the human developer simply devolve into a bottleneck?
It's a valid concern.
Right, because if you're spending all your mental energy aggressively proofreading fast code to ensure it isn't, hallucinating logic, you haven't really eliminated toil. You've just changed the flavor of the toil.
Yeah, this touches on the core anxiety of integrating generative models into production environments.
Right.
If the interaction model is AI writes, human reads, the human will always be a sluggish bottleneck.
Just overwhelmed by the volume.
But the stay in the flow methodology positions the human not as a proofreader, but as an architectural editor.
An architectural editor, okay.
The developer drives the conceptual logic through natural language prompts, such as instructing the AI to create an EKS cluster with auto-scaling enabled based on CPU utilization.
Right.
And the AI handles the syntax execution. You are shifting the human cognitive load from structural implementation to logical validation.
You are reviewing the structural integrity of the bridge rather than individually laying every brick.
Actually.
But even with the human acting as an architectural editor, speed at the creation layer immediately exposes the weaknesses in the downstream layers.
It always does.
Because if you are generating application logic and test skeletons in seconds, but you still rely on manual QA to validate the user interface, the whole system grinds to a halt.
Yep, you hit the nice wall.
The speed is wasted. You just move the friction from the developer's laptop to the QA department's staging server. So how does the blueprint solve the validation bottleneck?
It solves it by entirely reinventing the mechanism of testing in Pillar 2, the self-healing QA ecosystem.
Self-healing.
We discussed earlier how legacy UI scripts fail because they rely on blind, coordinate-based element locators.
Rigid pixels?
Right. The blueprint maps out a 4-step intervention process that replaces those rigid locators with model-based heuristic analysis.
Okay, so let's trace that process. Say a developer uses the Pillar 1 engine to rapidly rewrite the checkout flow of an e-commerce application. In doing so, the physical checkout button gets moved from the bottom left of the screen to the top right, and its internal CSS ID is completely altered.
Right. In a legacy system, that deployment is the trigger for a catastrophic test failure.
The pipeline halts.
Yep. The legacy script marches to the bottom left of the screen, fails to find the exact CSS ID, and crashes the pipeline. But the blueprint introduces platforms like Functionize to execute step 3, AI intervention via semantic mapping.
Semantic mapping. I love the personal assistant analogy for this.
Oh, it's a great analogy.
Because a legacy script is like a personal assistant you send to the grocery store with rigid, literal coordinates. You tell them, walk 50 paces north, enter the glass doors, and buy apples.
Right.
But if the grocery store moves across the street, that rigid assistant walks 50 paces north, crashes their shopping cart into an empty dirt lot, throws their hands up, and reports a total failure.
They just give up.
Yeah, they have no ability to adapt to environmental changes.
Semantic mapping gives that assistant situational awareness. What's fascinating here is it focuses on the meaning and intent of the action rather than the literal geometry.
The intent.
Right. When the AI intervention triggers, it uses object recognition to visually analyze the rendered DOM tree of the new website layout. It sees that the button in the bottom left is gone.
But it doesn't panic.
No, because it understands the semantic intent of the test, which is completing a purchase. So it scans the new environment, identifies a new button labeled Proceed to Cart in the top right, and deduces that this new element serves the exact same functional purpose as the missing one.
It understands the goal of the test.
Exactly.
And because it understands the goal, it can execute the final step, resolution.
Right.
It doesn't just flag the change for a human. It actively rewrites its own underlying test script to target the new locator, completes the checkout flow, and reports a successful green build.
It heals its own broken code in real time,
That's wild.
which entirely eradicates the concept of test maintenance churn. QA engineers are no longer spending the majority of their sprint cycles updating locators because of arbitrary front-end design changes.
Because the AI is doing the maintenance.
Furthermore, the blueprint points out that this heuristic analysis allows the AI to discover untested paths.
Untested paths.
Yeah, it doesn't just walk the single rigid hallway a human programmed. It dynamically explores the application's state matrix, behaving more like an unpredictable human user.
So it clicks around, it tries different input combinations, it maps the actual surface area of the application.
Exactly.
So we have Pillar 1, writing context-aware code at lightning speed, and Pillar 2, testing and healing that code dynamically. The application layer is effectively autonomous.
Basically, yes.
But software doesn't exist in a vacuum. It has to be hosted, networked, and secured. We have to move from the application logic to the foundational infrastructure.
Which brings us to Pillar 3, Generative Infrastructure as Code, or IAC. This tackles the friction of manual Terraform scripting and hidden server drift. The workflow here mirrors the coding engine, but applied to cloud architecture.
Okay.
The developer issues a natural language prompt, and the AI generates the complex Terraform configuration required to provision the necessary cloud resources.
But the critical architectural decision here is what the blueprint calls the source of truth. Right?
Yes.
The AI generates the code, but that code is immediately committed with standard organizational tags, triggering automated pipelines. The Terraform script remains the immutable source of truth.
Right. That's key.
No one is manually logging into an AWS console to tweak a server setting. If you want to change the infrastructure, you prompt the AI to update the code.
Maintaining the code as the absolute source of truth is what prevents the hidden drift we discussed earlier.
That makes sense.
And the performance metrics outlined here are substantial. The blueprint claims this generative approach reduces infrastructure provisioning time by over 60%, and environment creation time drops by 30 to 40%.
60%. That is a massive acceleration in spinning up testing or staging environment.
It really is.
But the detail in this section that genuinely alters the risk profile of cloud infrastructure is the assertion that the AI achieves this speed while simultaneously enforcing automated PCI-compliant data masking.
Yes. The inclusion of PCI compliance changes this from a speed optimization to a massive security safeguard.
I need to dive into the mechanics of this, because PCI compliance dictates how an organization handles highly sensitive credit card information.
Right.
When you spit up a fresh testing environment, you need realistic data to test against, but injecting real customer financial data into a staging server is a catastrophic security violation.
Huge liability.
So wait, how does the AI reliably differentiate between a random string of testing integers and actual legally protected, personally identifiable information?
Well, it uses...
Because if it scrambles the wrong data, the tests are useless.
Yeah.
If it fails to scramble the right data, the company faces massive legal exposure.
It relies on localized, purpose-built LLMs trained specifically on data topology.
Data topology.
Right. It isn't just looking for random 16-digit numbers. It analyzes the context of the database schema and uses format-preserving encryption and tokenization algorithms.
Oh.
If it identifies a string that passes the mathematical checksum for a Visa card or a structural pattern matching a social security number, it intercepts that data stream during the provisioning phase.
And does what?
It mathematically scrambles the sensitive values while preserving the structural format of the data. This ensures that the freshly minted environment is populated with highly realistic, functionally valid, but completely synthesized data.
So it builds the model home, and simultaneously ensures that all the real valuables are swapped out for perfect replicas before the doors are unlocked.
That's a great way to visualize it, and that happens on the fly, entirely automated.
So the infrastructure is provisioned securely, the application code is written, and the UI tests are healed. The final piece of the legacy friction ceiling is the deployment pipeline itself.
Pillar 4 introduces the AI-orchestrated CI/CD pipeline. We established that legacy pipelines are blind and linear. They run every test against every commit, causing massive staging delays.
Right?
The Blueprint's AI orchestrator dismantles that linear approach using 3 specific mechanisms, the most impactful being intelligent test selection.
Intelligent test selection. The document states this specific feature cuts pipeline execution times by roughly 50%.
Yes.
But how does an AI know which tests it can safely ignore without introducing risk?
By utilizing abstract syntax tree, or AST analysis.
AST. Okay, break that down for us.
When a developer submits a code change, the legacy pipeline simply sees a text-based comparison showing lines added or removed.
Just a before and after text file, basically.
Exactly. It doesn't understand the semantic relationship of those lines to the rest of the application, so it plays it safe and tests everything.
Makes sense.
AST analysis changes the paradigm. The AI parses the codebase and constructs a mathematical graph or tree mapping every single logical dependency.
Wait, so it maps the connective tissue of the entire software architecture?
Exactly. So when the AI analyzes the code diff, it traces those specific changes through the syntax tree.
Okay.
If a developer updates the logic for the front-end user profile rendering, the AST traversal mathematically proves that this change has 0 downstream dependencies on the back-end payment processing module.
Oh, wow.
Armed with that mathematical proof, the AI orchestrator dynamically prunes the test suite, executing only the specific subset of tests relevant to the altered tree branches.
It surgically targets the validation effort, cutting out 50% of the testing volume simply by eliminating useless, redundant checks.
Precisely. And that's just the first mechanism.
There's more.
Oh, yeah. The blueprint also details predictive failure analysis, where the orchestrator analyzes historical pipeline logs to spot anomalies and auto-apply known fixes before the build even fails.
Wow.
But the third mechanism, dynamic deployments, pushes the autonomy to a completely new level. It outlines how the system handles canary rollouts.
Okay, canary rollouts. A canary rollout is a standard risk mitigation strategy. You deploy the new version of the software to a tiny fraction of your live traffic, say 10% of users.
Right.
You monitor how it behaves in a true production environment before rolling it out globally. The vulnerability in legacy systems is the reaction time.
The human reaction time.
Exactly. If that 10% deployment introduces a critical memory leak, human engineers have to notice the alerts, analyze the dashboards, and manually trigger a rollback sequence.
And every minute that broken code sits in production, it's burning user trust and potentially revenue.
Exactly. But the blueprint states the AI orchestrator manages these canary rollouts dynamically, relying on real-time telemetry to trigger auto rollbacks if error rates surpass a hard threshold, like, say, 2%.
Yes.
If the latency spikes or the crash rate hits 2.1%, the AI instantly yanks the code back from the production environment, routes all traffic back to the stable version, and flags the precise failure point for the developers.
It executes risk mitigation at machine speed. Human reaction times are a liability in live production environments.
But we are placing an immense amount of trust in the machine to make final gonna-go business decisions affecting live customers.
We are.
I mean, if we step back and look at the architecture of these 4 pillars, we have context-aware code generation, self-healing test scripts, generative infrastructure pipelines, and intelligent deployment orchestrators capable of auto rollbacks.
It's an astonishing amount of automated velocity.
It really is. But if these pillars operate as isolated silos, it seems like a recipe for a high-speed disaster.
Oh, totally.
If the testing agent doesn't understand what the infrastructure agent just built, the system will collapse under its own weight. How does the blueprint synthesize these disparate tools into a cohesive whole?
This is where the blueprint moves from discussing individual tools to defining an ecosystem.
Yeah.
It introduces the concept of a closed-loop multi-agent ecosystem. It explicitly rejects the idea of isolated tooling.
So they have to talk to each other.
The agents operating within the 4 pillars are in constant communication, orbiting a central nervous system referred to as Opsera Unified Insights.
Opsera Unified Insights. So it creates a closed-loop brain through continuous feedback.
Exactly.
If the CI/CD agent executes that dynamic canary rollback we just discussed, the developer doesn't have to go hunting through server logs to figure out why their code failed.
Right.
The telemetry from that production failure is piped directly back into their IDE, providing the exact contextual data needed for the coding agent to suggest a fix.
The output of one pillar becomes the contextual input for another.
That's brilliant.
Yeah, the infrastructure agent can dynamically scale server capacity based directly on load metrics streaming in from the testing agent's heuristic analysis.
Right.
But the absolute prerequisite for this closed-loop brain to function is the data architecture feeding it. And the blueprint dedicates a critical section to this, outlining the telemetry funnel.
Subtitled, Making AI Measurable.
Yes.
The telemetry funnel mandates that every single AI-driven action across all 4 pillars must be tagged with highly specific metadata before it ever reaches the Central Insights dashboard.
Everything gets a tag.
It lists tags like a source, indicating which specific model generated the action, prompted, tracking the exact natural language instruction used, and Boolean flags like self-healed true.
Right.
But the tag that completely changes the dynamic is confidence score.
Oh, the confidence score is a brilliant mechanism for systemic self-awareness.
Self-awareness.
Yeah. When the generative engine produces a block of Terraform code or rewrites a test script, it doesn't just output the text, it calculates a statistical probability of its own accuracy.
Based on its training weights and the provided context.
Exactly. If it's generating boilerplate for a highly standardized, thoroughly documented API, it might output a confidence score of 99%.
Super confident.
Right. But if it's attempting to untangle a decade-old, undocumented legacy microservice, its statistical confidence might drop to 65%.
So it's attaching a quantifiable warning label to every single action it takes.
Yes.
Wait, so the AI is basically grading its own homework before turning it in?
Essentially, yeah. But it's doing it statistically. And all of this granular metadata flows through the funnel, which the blueprint notes uses over 80 connectors, aggregating into the Opsera dashboard.
The Opsera dashboard.
The explicitly stated goal here isn't just operational visibility. It's about translating engineering telemetry into board-ready metrics.
Board ready.
It specifically mentions DORA, space, and AI ROI.
Right, because the translation into business metrics is the only way a transition of this magnitude gets funded.
Exactly. DORA metrics quantify deployment frequency and failure recovery times. Space metrics analyze developer productivity and cognitive load. And AI ROI proves the financial case.
You need to prove it.
Without the rigorous tagging enforced by the telemetry funnel, the AI operates as a black box. You might feel like the engineering team is moving faster, but you can't mathematically prove it.
Right, you can't justify a multi-million-dollar architectural overhaul by telling the CEO, the vibes are really great in the coding department right now. You have to open the dashboard and demonstrate that 35% of all successful production deployments this month were initiated by generative models, and that the MTTR, the mean time to recovery, dropped by 40% as a direct result.
The telemetry funnel is the mechanism of proof, but visibility alone doesn't prevent disasters.
No, doesn't.
A highly intelligent, interconnected, well-measured system can still make catastrophic errors at the speed of light.
Like we said, it's a high-speed disaster waiting to happen.
A hallucinated configuration script could theoretically alter network security protocols or corrupt a production database before a human could even open the dashboard to see the telemetry.
Which transitions us to the absolute most critical section of the blueprint for anyone concerned with systemic risk, establishing AI guardrails and policy tiers.
The guardrail.
The document outlines a highly structured traffic light system designed to govern the exact boundaries of the AI's autonomy.
It's a very pragmatic approach to risk profiling. The green tier dictates full autonomy for high-confidence, low-impact scenarios.
Give me an example.
The document lists examples like fixing a documented syntax typo, updating non-functional documentation, or patching infrastructure drift that involves less than 5 lines of code.
Small stuff.
For these actions, the system applies the A-green tag, and the autonomy level is set to full pipeline execution. The machine identifies the issue, writes the fix, tests it, and merges it without any human intervention.
Okay, so that's green. What about amber?
The amber tier handles medium risk changes. The examples here include updating standard application logic or executing low-risk Terraform modifications.
And the tag.
The required tag is IAmber, and the autonomy level drops to standard peer review gate.
So humans get involved.
Right. The AI is permitted to generate the code, spin up the environment, and run the complete validation suite. But a human engineer must physically review the diffs and click approve before the code is merged into the main branch.
And then we reach the red tier.
The emergency brake.
Right, which acts as the architectural emergency brake. The triggers for a red classification are structural, attempting to alter the data schema of a database, modifying security group rules that dictate network access, or initiating data migrations involving live production environments.
High stakes.
Extremely high stakes. The system enforces an A red tag, and the autonomy is completely restricted to mandatory architect or security board review.
A single developer cannot simply approve an AI-generated change to the database architecture. It requires escalated multi-party human consensus.
Which makes perfect sense. The tiers themselves are highly logical, but, the enforcement mechanism is what makes this blueprint functional. How do you guarantee these tiers are respected across an organization of 1,000 developers?
The blueprint introduces the concept of the policy broker bot.
A policy broker bot.
The policy broker bot is the automated enforcer of the guardrails. It physically intercepts every single AI-generated pull request at the moment of inception,
Oh, wow.
acting as an unbypassable checkpoint between the developer's IDE and the central codebase.
It's literally the bouncer at the door of the repository.
That is exactly what it is.
And it executes a rigorous checklist. The very first check is a security scan. It utilizes tools like GHAS, GitHub Advanced Security, to search the generated code for leaked credentials or forbidden open source licenses.
Right.
Because generative models are notorious for occasionally hallucinating valid-looking API keys or pulling in code snippets encumbered by restrictive legal licenses.
It happens all the time.
If the bot detects either of these violations, the action is absolute. Reject an IDE. The pull request is instantly killed at the developer's workstation.
It refuses to even allow the tainted code to enter the testing pipeline.
Cut off at the source.
But if the code passes the initial security scan, the bot executes the second and arguably most brilliant policy check in the entire document.
Oh yeah, the unit test delta requirement.
Unit test delta.
The bot calculates the structural volume of the new AI-generated code and demands that the unit test coverage increase by a corresponding ratio. Specifically, it cites a threshold of plus 10%.
I love this mechanism.
I find this mechanism fascinating too because it effectively forces the machine to fund its own safety net.
Yes.
It's like a financial regulator telling a bank that for every new dollar of high-speed trading risk they take on, they must simultaneously deposit 10 cents into an untouchable reserve insurance account.
That's a brilliant way to put it. The AI cannot simply dump massive volumes of application logic into the system without simultaneously generating the rigorous test skeletons required to validate that logic.
It has to prove its work.
If the delta calculation falls below the required threshold, the bot executes a block merge action.
So it enforces quality by demanding mathematical proof of validation.
Only after the pull request passes the credential scan and the unit test delta calculation does the policy broker bot evaluate the contextual risk, apply the green, amber, or red tag, and route the request to the appropriate human or automated gateway.
Okay, but this brings up a massive operational contradiction that I'd really have to challenge.
Let's hear it.
We started this deep dive analyzing the legacy friction ceiling, right? Right. And the entire premise of the NoOps horizon was achieving unprecedented velocity by eliminating manual toil.
Yes.
But we have just outlined a system that intercepts every action, runs credential scans, demands mathematical test coverage proofs, blocks merges, and forces architectural board reviews for database changes.
It sounds like a lot of red tape.
Does the introduction of this incredibly heavy, automated governance negate the speed benefits we gained in Pillar 1? Have we just replaced manual friction with automated red tape?
So, what does this all mean? It's a critical pushback, but it misinterprets the nature of friction in software delivery.
Okay, how so?
The friction ceiling of legacy DevOps wasn't caused by the existence of security checks. It was caused by the latency of human-driven security checks.
Oh, the waiting.
Exactly. Waiting 3 days for a security engineer to manually review a pull request is friction.
Yeah.
The policy broker bot executes credential scans and syntax tree delta calculations in milliseconds.
Milliseconds.
Yes. It might block a merge, but it blocks it instantaneously, providing the exact contextual error back to the developer while they are still in the flow state.
Which allows for immediate correction.
Exactly.
So the governance operates at the same machine speed as the creation engine. You can only safely generate code at blinding speed if the guardrails evaluating that code can process the risk at an equal velocity.
Exactly. The goal of NoOps is not reckless acceleration. It is frictionless momentum within mathematically verifiable boundaries.
Okay, we have mapped out the theoretical architecture. We understand the coding engine, the heuristic QA, the generative infrastructure, the telemetry funnel, and the bouncer bot enforcing the guardrails.
It's a complete system.
But the transition from a messy legacy DevOps reality to a fully integrated NoOps ecosystem cannot happen overnight. You can't just mandate this shift on a Friday and expect 1,000 engineers to adapt by Monday without completely destabilizing the company's live production environments.
Which is why the blueprint concludes its technical specification with a highly rigid deployment strategy. The sequenced migration blueprint.
The migration blueprint.
It maps out the transition across exactly 14 weeks.
14 weeks. That's a single fiscal quarter to entirely rewire how a company builds software.
Is this an aggressive speed run, or is AI adoption forcing a new cadence on corporate IT?
It is ambitious, but it avoids chaos by structuring the migration into 4 distinct mathematically gated phases. The brilliance of this migration plan lies in the exit criteria.
Oh, the exit criteria.
A phase does not end simply because 2 weeks have passed.
Right.
A phase only ends when specific telemetry thresholds are mathematically achieved and proven in the ops or dashboard.
So you have to earn your way to the next phase. Let's trace that timeline. It begins with phase 0, spanning weeks 0 to 2, labeled the proof of concept.
Right.
An internal AI guild establishes an isolated sandbox environment. They integrate Copilot, Functionize, and IAC agents, but they restrict the activity to dummy pull requests.
They aren't touching live code. No, they are simply verifying the connective tissue between the agents. And the exit criteria to escape the sandbox is incredibly revealing.
The exit criteria is custom open telemetry tags reach Opsera insights.
Before they write a single line of functional business logic, they must prove that the telemetry funnel is working.
Exactly.
They must prove they have the capability to track and measure the AI's actions. If the dashboard is blind, the migration stops.
Visibility is the absolute prerequisite for scale. Once telemetry is confirmed, they move to phase 1, pilot service, covering weeks 3 to 6.
Okay, and what happens here?
The scope here remains highly restricted. They select a single engineering squad and deploy the toolset onto a contained 1K LOC microservice, 1,000 lines of code.
So it's a localized experiment on a real but low-risk piece of architecture.
Right. And the exit criteria for phase 1 dictates that the AI-accepted lines of code must be greater than or equal to 15%, and the functional testing suite must achieve a 50% self-healing rate.
Meaning the human engineers must voluntarily accept at least 15% of the AI's generated logic, proving it provides actual utility.
Yes.
And the QA agent must successfully heal half of the broken UI locators autonomously.
They have to mathematically prove the value proposition of pillars 1 and 2 on live architecture.
Wow.
Achieving those metrics unlocks phase 2, code and test expansion, occurring in weeks 7 to 10.
This is the moment of mass integration.
The toolset expands org-wide. The blueprint notes the introduction of global Copilot and GHAS unit test mandates. But, crucially, to manage the chaos of 1,000 developers suddenly utilizing generative models, this phase introduces a prompt library v1.
A prompt library. Because if they prove the value on a microservice, the immediate temptation is to just hand the tools to everyone.
But doing that without standardizing how the engineers communicate with the AI models would create massive architectural inconsistencies.
Right. So the prompt library codifies the optimal tested natural language instructions required to generate code that perfectly aligns with the company's specific design patterns.
Prompt engineering transitions from an individual art to an organizational standard. And the exit criteria for this expansion phase reflects that priority.
Which is?
Prompt library reuse greater than or equal to 60%.
So they are actively tracking the behavioral compliance of the engineers.
Yes.
If the developers aren't utilizing the standardized prompts, the rollout halts. Consistency is the mechanism for safety at scale.
Exactly.
Finally, assuming compliance is met, they enter phase 3, infra and operations spanning weeks 11 to 14. This activates the final pillars, engaging predictive scaling for server environments and routing all pull requests through the active policy broker bot.
And the ultimate exit criteria validating the entire 14-week migration.
Yeah, what is it?
AI value score tied to steering committee metrics.
So the final validation isn't even a technical threshold, it's a financial one.
Right. Did the transition actually move the needle on the business goals?
The rigid phasing ensured that by the time you reach week 14, the answer is already mathematically guaranteed.
It has to be.
But this brings us to the most profound and perhaps unsettling implication of this entire document.
The human element.
Yeah. If an enterprise successfully executes this 14-week migration and achieves the NoOps horizon, where 95% of routine operational toil is fully automated, what happens to the human beings?
It is the ultimate question underlying the entire transition. The blueprint dedicates its final section to addressing the human operator in the NoOps era.
Yeah.
It forcefully argues that generative AI does not replace the engineer, it replaces the mechanical toil.
Right.
By moving the execution of syntax to machine speed, the human operator is forced to ascend to what the document calls strategic heights.
The manual coder evolves into an architectural thinker.
Exactly.
The blueprint maps out three entirely new roles for the human operator in this ecosystem. The first is the automation architect.
Right. If the AI agents are constructing the software, the automation architects are the humans constructing the boundaries for those agents.
Okay.
They are the individuals designing the complex guardrails, defining the logic of the green, amber, and red policy tiers, and writing the open policy agent rules that govern the multi-agent ecosystem.
They transition from building applications to engineering systemic governance and compliance frameworks.
They program the bouncer bot.
The second role is the quality strategist. This is the evolution of the QA engineer who previously spent their days desperately rewriting brittle UI scripts.
Right. Because the heuristic models are now automatically exploring the DOM tree and healing the element locators, the human is liberated from script maintenance.
And what do they do at that time?
The quality strategist redirects that massive surplus of time toward deep exploratory testing, acting as the unpredictable, chaotic human user to uncover nuanced edge cases.
And domain logic validation, ensuring the software solves the actual business problem, not just the technical requirements.
Exactly.
And the third role outlined is arguably the most transformative: product creator.
Oh, definitely.
The blueprint explicitly defines this role through the concept of design by conversation. These individuals bridge the gap between complex business needs and the IDE's natural language processing capabilities.
If we connect this to the bigger picture, this represents the ultimate philosophical shift from syntax to strategy.
From syntax to strategy.
Yeah. Historically, the primary value of a software engineer was their mastery of the rigid syntax of a specific programming language. Knowing exactly how to structure a loop in C++ or format an array in JavaScript.
Right.
In the NoOps era, the generative models possess a mastery of syntax that vastly exceeds human capability.
Wow.
The value of the human is no longer the translation of logic into code, it is the conceptualization of the logic itself.
Design by conversation. You're interacting with the entire closed-loop ecosystem using plain English.
Plain English.
You define the architecture, dictate the security constraints, and articulate the business objectives, and the ecosystem synthesizes the Terraform scripts, the application logic, and the validation suites required to manifest that objective.
It's incredible.
Which makes this blueprint incredibly relevant to you, the listener, right now, regardless of where you are in your career.
Absolutely.
I mean, if you are a junior developer or a computer science student listening to this right now, should you even be memorizing coding syntax anymore? Or should you be majoring in logic and communication to be a product creator?
It's a valid question. The premium market value is shifting heavily towards systems thinking, architectural risk assessment, and the ability to articulate highly complex problems with extreme clarity.
Let's pull all of these threads together.
Okay.
We began by examining the diagnostic muddy waters of legacy DevOps, the cognitive drain of context switching, the endless churn of brittle UI scripts, the invisible danger of infrastructure drift, and the massive bottlenecks of linear testing pipelines.
The friction ceiling.
We explored how the Catalyst to Autonomy blueprint systematically dismantles that friction ceiling across four interconnected pillars.
The context-aware coding engine that preserves the developer's flow state. The heuristic QA agents that utilize semantic mapping to heal their own test scripts.
Pillar 2.
The generative infrastructure that provisions environments while mathematically enforcing PCI-compliant data masking on the fly.
Pillar 3.
And the intelligent CI/CD orchestrator that leverages abstract syntax tree analysis to dynamically prune validation suites and execute sub-second canary rollbacks.
Pillar 4. We analyzed how those pillars are bound together by the Opsuri Unified Insights brain, heavily reliant on the telemetry funnel, demanding confidence scores for every machine action.
Right?
And we saw how the entire ecosystem is aggressively governed by the policy broker bot, forcing mathematical unit test deltas and enforcing strict risk-based autonomy tiers.
Culminating in a highly rigid 14-week sequenced migration plan that mathematically gates every phase of adoption.
Ultimately elevating the human operator from a writer of syntax to an automation architect, quality strategist, or product creator.
It is a blueprint for entirely rewiring how human intent is translated into functional technology.
But as we wrap up this deep dive, I want to leave you with a final thought to ponder, building directly on that concept of design by conversation.
Let's hear it.
If the AI agents in this NoOps ecosystem achieve near-flawless execution of syntax based purely on natural language prompts, does the traditional hard dividing line between a business person and a software engineer begin to permanently dissolve?
Oh, that's a profound thought.
I mean, within the next decade, if you no longer need to know how to code to build enterprise-grade architecture, will the most valuable and highly compensated technical skill simply be the ability to articulate a problem clearly?
Just being able to describe the cure.
Exactly. From a broken X-ray machine to a future where merely knowing how to precisely describe the cure is all that is required to build it. Thank you so much for joining us on this deep dive.
Thanks for having me.
Keep analyzing the friction in your own daily workflows and keep exploring the accelerating horizon of tech autonomy. We will see you next time.